Okay, here we go. I have a box here. This box isn't that heavy. I mean, you know. Ugh. Alrighty. So I'm going to choose 2 people to put this box up on this cart, and I want you to compare how these 2 people do it. The first person I'm going to ask is, I hope you don't mind, Lily. Come on up. Please put this box on that cart. Now remember to lift with your legs. I don't want to hurt you or anything. I'm choosing Lily because she is the littlest girl, the liliest girl. Okay, please watch as she does it. And don't hurt yourself. See how much time it's taking her. Okay. But she did it. Yay. Thank you very much. Now, I need a big, strong guy who will do this incredibly fast. I'm thinking more of an, I think maybe Justin. You want to do it, Justin? You feel like it? You look big and strong. Look at him, look at his arms. Do you work out or are you just born that way? Oh, good for you. Please, watch this, he does it. Look at this. Thank you very much. So, here's my question to you guys. Who did more work, Lily or Justin?
They both did the same amount, my friend.
Wait, what? Imani, what did you just say?
They both did the same amount, my friend.
My friend. Yeah, they both did the same amount. You guys okay with that? They both lifted the same box, the same distance up. They did the same amount of work. But let me ask you this. Suppose I had a room with 150 carts and 150 boxes, and I had to hire somebody to put all those boxes on the carts. Who would I hire, Lily or Justin?
You could do either.
Thank you. I would hire Justin, right? Why would I hire Justin?
More efficient.
Yeah, he's more efficient. You guys okay with that? He can do it faster, right? Faster. So I'm not measuring the amount of work they would do. Even if I hired Lily to do a room full of these, she would do the same amount of work as Justin. But I need a quantity, I need a measurement, so a way to measure the efficiency, to measure how much time it takes them to do it. The fact that Justin can do it way, way quicker than Lily, and the unit of work is not sufficient for me to make that determination as to who I should hire to do a room full of boxes. And that gets us to our next quantity that we're going to learn about, and that's power. So here it comes. Power. Power. Poder. Poder. Tengo más poder. Power. What power is defined as is it's work per unit time. It's not just how much work you do, it's the rate at which you do work. Work over time. If you take less time but do the same amount of work, then you're exerting more power. You're doing more power. And since work is what we do to change the energy of something, or energy is the capacity to do work, and work and energy both are joules, we can also say power is energy over time as well. Okay, let's do a quick example so you can practice plugging in. Here's example number 1. You lift a 200 Newton weight up 1.5 meters in 0.50 seconds. How much power did you exert or use or do? Good luck. I'll give you a hint. Please use this formula.
I realize.
Okay, so are you guys getting 600?
Yeah.
You're exerting 200 newtons of force over a distance of 1.5 meters, that's 300 joules. Over 0.5 seconds, that gets 600. And do you see that the units are going to be joules per second? So that's the units of power, joules per second. Great. Except for one thing. We would like to honor another dead white guy.
Wonderful.
A guy who was like the father of the Industrial Revolution. He invented processes and engines that made it really efficient to turn like sheep into wool, suits, I guess. What do? You take a sheep and do something to it, and now you got a wool suit. However that works. His textile manufacturing firms were really good at doing that. And you know who this guy was? Yeah, James Watt. James Watt. And so we're not going to call it 600 joules per second, no siree. We're going to call it 600 watts to honor James Watt. You guys okay with that? Okay. And there's not much more for me to say. You'll get some problems on tonight's homework, but they're all just mindlessly using the formula. Just remember, power is a measure of how much work you do per unit time, or how much energy you're using per unit time. Let me say one more thing about energy, and this pertains to your home, okay? When your dad or mom gets the electric bill, they do not tell you how many joules of energy you used. They tell you how much energy you used in kilowatt hours. Kilowatt hours. Kilowatt hours. For example, do you know how much power does a 100 watt bulb use? Anyone think? Go ahead. Yeah, 100 watts. That's pretty stupid. Yeah, so you got a 100 watt bulb, okay? And it uses 100 watts of power. That is, it's using 100 joules per second. Every second you leave that bulb on, you're using 100 joules of energy, which is a significant amount of energy, right? I mean, I exert 100 joules if I lift a 100 Newton weight up 1 meter. The energy it takes me to lift a 10 kilogram mass up 1 meter is 100 joules. And this 100 watt light bulb is using 100 joules every second. So tell me, in response to this, what does your dad do as he prowls around the house? Yeah, turns all the lights off, right? Because he's very much aware that he's paying for that energy. So if you're using 1 kilowatt hour, that would be like having 10 100 watt light bulbs on for 1 hour. That would be 1 kilowatt hour, 1,000 kilowatts for 1 hour. And that happens in my house occasionally. I'm the only one who turns lights off in my house. So sometimes literally every single light bulb in my house will be on. And I have to go through all of the rooms turning off every bulb. There was like one time there was like 20 bulbs on, unnecessary, 20. So I'm using this just stupendous amount of kilowatt hours. Well, so in a given month, I might use 150 kilowatt hours. I think that's about what I use, 100, 150 kilowatt hours in a month. If you have an air conditioner that uses up a tremendous amount of energy. I just want you to see what a kilowatt hour is in joules. And you're going to get a problem that actually asks this. So I need to kind of get you there. 1 kilowatt hour. The way you're going to convert this to joules, first of all, I don't want kilowatts, I want watts. So I need 100 watts in 1,000 watts in 1 kilowatt. And now I get rid of the kilowatts and I have watts. And I've got 3,600 seconds in 1 hour. And now I've got rid of the hours. And you end up having 3.6 million joules. .6 million joules. Oh wait, I skipped a step. So I got watts per watt seconds, 3.6 million watt seconds, but a watt is a joule per second. And so I got 3.6 million joules. All right, so that's it. So, you know, if you had your electric 5 more minutes, yeah, I'm almost done, so that's worked out just perfect. So on your electric bill, they don't want you to have to look at your electric bill and go, I used 457,547,262, you know, joules. They would rather have it be a simpler number, like 150, you know? So that's why your electric bill is not measured in joules, it's measured in kilowatt hours. Plus, you know, it's easier for Americans to kind of think in terms of, well, I got a 100-watt bulb on for 1 hour, so that would be 100 watt hours and 0.1 kilowatt hours, I don't know. But anyway, I just want to let you know that's how we do it. 3.6 million joules in 1 kilowatt hour. Alrighty, at this point, hey, I'm done with the direct instruction part. Now we're going to do conceptuals, but yeah, you can turn that thing off.